This occurrence is not directly related to airborne geophysical survey. It's a wire strike occurrence that we had on a firefighting operation. Probably 75% of our work within United Aero Helicopters is firefighting work, as opposed to we're very heavily invested in airborne geophysics, but we do a lot more firefighting work than we do airborne survey. We're actually quite exposed to the wire environment in that firefighting operations, and so we do pay a lot of attention to avoiding power line strikes. I've been involved with a couple over the years, and we're very much aware of the dangers that wires pose. This particular incident was during firefighting operation in January last year, so a little over 12 months ago. We were working a Bell 412 SP out of the ACT, one of the firefighting contracts that we have. We have two machines based in Canberra, a Squirrel and a 412. This machine was working 3 nautical miles west of Sutton, which is just north of Canberra City, and for anyone that knows that area. It occurred at approximately 18 minutes past 5 in the afternoon, which is important to note because it gives you a bit of an idea of what the sun angle was at the time. As I said, it was on aerial firefighting ops. It was on actual water bombing operations as opposed to observation and crew insertion. On board was 1 pilot and 1 crewman, both highly experienced. The pilot is a 10,000 plus hour pilot. The crewman in his early 50s is a career crewman, having been a crewman for the last 30 years. Much to our, I suppose, relief, there were nil injuries and very little damage to the aircraft. And for anyone that's dealt with power line strikes before, that's not a very common outcome to have. There's, generally speaking, at the very least, substantial damage to the aircraft. The conditions of the day, there was greater than 10 kilometres of visibility with, it says occasional smoke there. Where the aircraft was actually working was outside of the smoke zone. I'll show you some photos in a minute. You'll get an appreciation of what the conditions were like. But they were outside of the smoke zone. There was a lot of smoke in the area. It was 34.2 degrees Celsius, and I can't remember why we have the temperature so accurate, but somebody must have provided that. And the wind was a westerly at 15 knots, and it was daylight operations, obviously. That is the actual aircraft you can see right there. So I did up I went to site the following day after the accident and did an investigation. And as part of the investigation, I've just done this up utilising Google Earth. This is, which is the button there for the, oh, there it is. So this is the dam in question here where the aircraft was pulling water. Now, on this particular day, there were very fast-moving grass fires moving through this entire area, which you'll see on the next slide. The aircraft was choosing multiple dams as the fire was spreading to try and contain certain flanks of the fire. There is a large transmission line which is indicated by these blue lines at the bottom here. There's a property over here. There is the dam that the aircraft was using here, and there is a power line that runs, which is indicated by this white line here, that crosses across to here and comes into this house here. This is a slight depression through here, and you'll see on the topography of the country in some of the slides, but in most gauges it's very light depression and would be considered, you know, in the flat range with regards to most risk assessments on airborne survey. So as you can see, that's north, west. So the aircraft came in. I'm not sure if we've got the slide in for the actual aircraft manoeuvring, but the aircraft flew in from this location, turned around here and made an approach to the dam at that point there. That photo there was taken 7 minutes after the occurrence, and it's actually looking to the southeast. So this was taken from the air attack platform. When we're fighting fire with multiple machines, we have an air attack platform overhead, and they're often giving you advice on which dam to use. So what had occurred here, you can see the transmission line through here. The property which is just out of shot that I showed is back over here. This spot fire here had jumped over the line, and obviously you can see from the direction of the smoke and the wind was threatening this property over here. For anyone with a keen eye, you can actually see a helicopter working right there. It's a Black Hawk bucketing out of that same dam after the occurrence. Our machine had struck the power line and was able to manoeuvre the aircraft and land just out of shot back over here. So you can see it's quite a dynamic environment. The aircraft, the fire itself was quite large and spreading. Quite a bit of pressure on the flight crew to contain these kind of spot overs as they got out, and because of the spread of dams, the pilot was choosing the most appropriate dam to use for that particular area of the fire. I might just give you a bit of an idea on what occurred. So this is the southern pole on the line. So this was the one closest to the transmission line. You can see the fire spread around the base of the pole here, which is where the spot over had started. This is separate to the main body of the fire. You can see the dam just down here where the pilot made his approach to take a load of water, and this was his departure path. You can read, for anyone that knows about power line avoidance and looking at hardware to determine where the power line runs, you can see from the hardware here that it's quite obvious that there's a line running east-west parallel with the transmission line. There's a stay arm or a guy wire on this side of the pole and a cross arm there indicating that there's a wire heading due north. That up there is the northern pole, and the span from this pole to that pole was 550 metres. But as you can see by the ground, it would be considered relatively flat. So that's standing on the back edge of the dam, looking up to the North Pole, which was up against the bank of trees and, you know, expertly concealed. That's standing on the back of the dam, looking back towards the southern pole, which unfortunately was also concealed by smoke. Now that's standing on the dam, actually looking, and there you can see the wire across there. Now keep in mind it was 5:20 in the afternoon, so the sun would have been up here somewhere, more or less in the pilot's eyes. So what's actually occurred is the pilot's come into the dam, made his approach. As per company procedures, he's conducted a steep approach out of the dam site. At some point during the climb out, he's noticed a power line across his windscreen. So he's backed away from the power line, which you have the luxury of in a helicopter, obviously not a fixed wing. Dumped his water, flown over to a paddock on the other side of the house away from the fire danger, and made an inspection and alerted everybody. On inspection, we found wire graze marks up the nose of the helicopter. We found wire graze marks on the pitot tube and a little bit on the painted section back there. As you can see, they're quite light grazing marks. We found grazing marks up the spine of the wire strike protection system. I'm not sure if everybody understands what a wire strike protection system is, but it's designed as a last line of defence to catch the wire and cut it before it gets entangled in the rotor system. The wire actually stopped here. This is where the pilot slid up the screen. The pilot saw it and was able to arrest any further climb and back away from it and release his load of water. There was no evidence of the wire contacting the actual cutters in the wire strike protection system as it stopped back down here. Unbeknownst to us, when we did our initial inspection, the blades had contacted the wire. Because the blades, working in a fire environment like that, we're in smoke a lot, the blades become quite black from soot. These blades, that picture there is actually tiger marks from the wire, the blades striking the wire, and all 4 blades had struck the wire. And what we had determined on further inspection, that what had actually occurred is with the 2 wires, the pilot had climbed out and he cut the first wire with his blades, completely unknown to him. And what had happened, once the first wire was cut, which was this wire closest to the dam, there was no more even tension on that crossarm, and the crossarm spun around and the second wire dropped, which brought it from blade height down to nose height. And that's when he saw the second wire on the screen, having already cut the first wire with his rotor system. This picture here was after the blades were cleaned, and that was detected. The blades were subsequently cleaned further with, miraculously, not one shred of evidence that there had been a power line strike. This was just my summary on the occurrence and some outcomes. We understand that the environment we work in is a very high risk factor with regards to power line strikes, and we were, it wasn't lost on us the fact that we were exceptionally lucky in certain aspects of this. There were some aspects though that weren't to do with luck. This power line would be considered a very bad power line by anyone's standard because of the length of the span. Obviously, the mitigating circumstances with regards to, or the circumstances with regards to the fire added another dimension to it. There was pilot pressure, to get the fire out. There was smoke. There were certain aspects that you wouldn't normally have on an everyday airborne survey job. That obviously doesn't diminish the responsibility to ensure proper reconnaissance before you go low level, but it adds another dimension to it. Smoke and sunlight made the power line very hard to see. Certainly made the hardware difficult to identify, with one pole being in the smoke and the other pole being up against the bank of trees, which we talk about all the time. We understand poles are often hidden. You have to go looking for them. There was sound CRM between the pilot and the crewman. It should be noted it's not standard practice for us to have a crewman on board whilst we're water bombing. It's a little bit as we say with our geosurvey operations. We prefer not to have an operator or a crewman on board unless there's a safety case to have that person on board. Obviously, you diminish the consequence by having less people, the severity of the consequence by having less people on board. In this circumstance, because it was such a dynamic environment, lots of aircraft working, multiple power lines, fast-moving fire, it was standard practice to put the crewman on board as an extra set of eyes. From all accounts, after interviewing the pilot and the crewman, there were very sound CRM practices occurring in the cockpit on that day. I've written a comment there about power line strikes. As we know, all power line strikes are avoidable. It seems that some are more avoidable than others, given the circumstances of this and the type of power line. We have to recognise that. In a less pressured situation, with no fire and smoke, the crew would most likely have identified a pole and the hardware which they're trained to do. What I asked the crew during the investigation was, what could you have done to prevent this occurrence? And really the main thing that they could have done is a complete orbit before descending into the hole. We trained for that. We trained for identifying these hazards before we descend to low-level operations. The crew were calling out power lines. They were calling out hazards on their way down. Slightly poor procedure, given that, for one, it was a left-hand turn into the pole as opposed to a right-hand turn, although we did have pilot on right-hand side, crewman on left-hand side, so two sets of eyes. The pilot and the crewman were calling out power lines on descent, assessing wind conditions and fire activity as well. But they failed to do a complete orbit, which should have identified the pole on the northern side and alluded to the potential for a power line crossing in front of that path. One of the positives that came out of it was reaffirming our company procedure for remote area landings and takeoffs to previously unidentified locations using, power over speed. It's company standard in those situations to use maximum power departures where we're a lot steeper. And what that does is it allows the crew to observe any last-minute hazards that weren't previously identified and react. It's been documented in our ops manual for a lot of years. I documented it in an ops manual for a company I used to work for in 2004, where we had a power line strike that resulted in a double fatality. We spent a lot of time working with industry representatives at that time and talking about how do we get pilots to, in particular on that occasion, was how do we minimise the potential for pilots to fly into power lines that they'd already identified, because that was a power line that was identified and then forgotten about. And one of the techniques was for a departure to have a steep departure out, and the crew were practising that on this particular day. And it's a last line of defence, but that last line of defence was enough to prevent this accident or this occurrence becoming a catastrophic occurrence. As a result of the accident, these are some of the actions and recommendations. We've provided all personnel with a copy of the investigation report and discussed collectively with each pilot and crewman the details of the occurrence and how it might have been prevented. That's the question I put to our crew, because at the end of the day, none of us go to work in the morning expecting that we're going to fly into a power line. So I asked them, well, if the expectation is that you're not going to fly into a power line, how are we going to prevent that? How can we guarantee 100% that today I'm not going to fly into a power line? Revise the operations manual to more clearly define requirements to conduct a complete orbit and use sun angle and other techniques to help identify particularly difficult wires. These are techniques we use. We just more clearly identified that requirement for a minimum of one complete orbit before descent into a site, taking into account terrain and other potential areas that might conceal poles, like tree banks or forests or whatnot. We've strengthened training techniques for pilots and crewmen to respond to high pressure situations and maintain safety margins by maintaining effective lookout. Some of the areas there we work on are empowering the pilots to realise that they have to give themselves the time to conduct that orbit, even in these pressure situations where we have fire situations. Obviously, on an airborne survey perspective, that same sort of time pressure is not there, so there is no excuse. So that's one of the areas we work on with our fire crew. Provide additional training material in the form of online safety videos to all flight crew. I'm a firm believer in looking at other accidents and videos of occurrences and working out, how we can not get in that situation. And finally, we continue to put our pilots through CRM and fly in the wire environment courses, and we discuss with other aviation bodies this occurrence. I've provided this occurrence report, and I'm happy to do so, the full report, to anybody that wants it individually, to aviation utility specialists that conduct a lot of the Bob Feist, and I don't know if any of you know that have done the fly in the wire, CRM in the wire environment course. I provided these reports to him and similar reports so that they can use them as required in their seminars and so on.